All right, 6.2, day 3. At this stage of the game, all the background facts, formulas, important stuff like that, we've already covered. The focus for today is practicing these in problem-solving situations of knowing what rule to use where. Okay, for this PowerPoint, these are a sampling of even number questions from the section. So if you've been following along in a textbook and you've been looking at the problems in this particular section, you realize that these are pretty much the evens, or the better even problems that are worth doing. For the most part, the homework over the last couple of days were the odds from section 6.2. All right, on to the problems at hand. Rotter Partners is planning a major investment. From experience, the amount of profit, X, and this is in millions of dollars, on a randomly selected investment of this type is uncertain, but an estimate gives estimate gives the following probability distribution. So this is the profit in millions of dollars and what the probability is of obtaining that profit. Okay, based on this estimate, the mean is 3 million, and again, you could figure that out through one variable statistics on your calculator if they didn't give it to you, and the standard deviation is this. Rotter's Partners owes its lender a fee of $200,000 plus 10% of the profits of X. So the firm actually retains. So if it has to give away or owes somebody else 10% of the profits, it means they're keeping 90% of the profit, and then they have that flat rate that they have to pay. So from the investment, find the mean and standard deviation of Y. So mean is affected by both the multiplication and the subtraction. Standard deviation is only affected by the multiplication, not the subtraction. So, in terms of showing work, blank formula. Plug in the numbers, final answer, include your label. Blank formula. Plug in the numbers, final answer, show the formula. Anna is a dedicated skee ball player. Who is it? Who always rolls for the 50-point slot. The probability distribution of Anna's score X on a single roll of the ball is shown below. You can check that this is the mean, this is the standard deviation. So we don't have to get that information from here, but we could using our calculator. A player receives 1 ticket from the game for every 10 points scored. Let T equal the number of tickets Anna gets on a randomly selected throw. Find and interpret use of T. So these are your scores, and for every 10 points, you're going to get a ticket. So 1/10 of this will give you a ticket. 1/10 of that will give you a ticket, etc., etc. Or use of T is 1/10 of use of X. Blank formula, plug in the number, final answer with unit. Okay, the interpretation of that, after many, many rolls, Anna will receive an average of about 2.38 tickets per roll. Did they ask us specifically for the interpretation? Oh, find and interpret. Okay, when you're interpreting the mean of a probability distribution, you always want to indicate that many, many trials, in this case, the many, many rolls. Expected values or means should be expressed as decimals. That's showing you understand it's impossible to get 2.3 tickets, 8 tickets just for one roll, but on average of many, many rolls, you'll get about 2.38 per roll. Okay, find and interpret the standard deviation. Well, standard deviation is affected by the multiplication. Blank formula, plug in the numbers, final answer with unit. The number of tickets that Anna wins will typically vary by about 1.263 from the mean of 2.38. When you're interpreting standard deviation, the wording that you want to use is will typically vary from the mean by about. You have to have the context. We're talking about number of tickets, and refer back to that mean that we already figured out. Miss Hall gave her class a 10-question multiple choice quiz. Let X equal the number of questions that a randomly selected student in the class answered correctly. The computer output below gives information about the probability distribution of X. To determine the student's grade on the quiz, out of 100, Ms. Hall will multiply his or her number of correct answers by 5, then add 50. Let G equal the grade of a randomly chosen student in her class. So N is 30 people in the class. Mean, standard deviation, median, min, max, Q1, Q3. Okay, find the median of G. Well, what we need to do is get an expression for what is the distribution of G. It's 5 times X plus 50. Your raw score times 5 plus 50 as described by the problem above. So the median is a measure of center. We're going to treat that the same way we treat mean. It's going to be affected by both the multiplication and the addition. So we defined our distribution G. We have our formula with the number plugged in. The median of that is going to be 5 times the median of the distribution X plus that. The median of the new distribution is 92.5. And usually for scores, again, they don't require to have the points, but it's more thorough and better to have that there. It's always better to have a label than not in a situation like that. Okay, find the IQR of G. The IQR is a measure of spread. We treat that the same way we treat standard deviation. It's affected by the multiplication, but not by the addition or subtraction. So for the IQR of G, it's just 5 times, and then the 9 minus 8, that would be the IQR here. The IQR is 1, so the IQR is 5 points. Okay, what shape would the probability distribution of G have? Justify your answer. The shape of G's probability distribution will be the same as the shape of X's, because the distance between the median and the minimum is much greater than the distance between the median and the maximum. Both distributions are probably skewed to the left. Another indicator of this skewness to the left is the fact that the mean is less than the median. So although it didn't specifically say what this distribution is, we can take a good guess of what it most likely is. The one that I think is better to concentrate on is that mean being less than the median. That's probably the one thing to focus on in terms of that's an indicator of it's probably skewed left. It's not guaranteed to be skewed left, but it's an indicator that it is. So make sure you use verbiage that indicates that indicator of it probably is. Don't use wording that's going to be indicating that it definitely is. Okay, a company's single-serving cereal boxes advertise 9.63 ounces of cereal. In fact, the amount of cereal X in a randomly selected box follows a normal distribution with a mean of 9.7 and a standard deviation of 0.03. So they're on the safer side in terms of they're advertising this, but usually there's more. So that would be good business practice because you don't want to be necessarily accused of having less. If you're not going to be able to hit that exactly, better to have it a little bit more than a little bit less. All right, let Y equal the excess amount of cereal beyond what's advertised in a randomly selected box measured in grams. And they give you the conversion. That would never be anything you'd have to know for the test. In a quiz or test in here, they would always give you that. Find the mean and standard deviation of Y. So, what do we have going on here? Let Y equal the excess amount of cereal beyond what's advertised. So, it's the 9.63 is what's advertised. X is how much you get. So in general, it'll be X minus the 9.63. That's why that's there. But we also have the deal of we're converting it into grams. So we have to multiply by the 2.38. I'm sorry, 28.35. I have no idea why I said that number. This cleans up a little bit. So there is our new distribution. So looking at the difference between what you get and what's expected and converting that into grams, this is our new distribution. So the mean is affected by both the multiplication and the subtraction. The standard deviation is affected just by the multiplication. Make sure you have your subscripts to indicate what's what. X is what you actually get. And then Y is the excess over what they are advertising. All right, as I had mentioned, I don't know if that happened today or yesterday's PowerPoint. A very common AP question will ask you to do some kind of transformation like this, and then ask you a follow-up question about some kind of probability. So find a probability of getting at least 3 grams more cereal than advertised, show your work. Well, they're never going to say, well, never is a strong word. It's unlikely they're going to say, show your work. It's implied that you're showing your work here. You should never have a naked answer for an AP question. Using technology, the command lower, upper, mean, standard deviation. So at least 3 grams is greater than 3 grams. That's the lower, upper, and this is a continuous probability distribution, so we don't care whether the actual 3 is included or not. That goes in as is. And then we have the mean and the standard deviation that we just calculated go in those 2 slots. That gives us our area. There's an approximate 0.11 or a little bit less than a 12% chance of getting at least 3 grams more than advertised. Another AP note, without these labels, you're not getting full credit. You're already allowed to abbreviate this. That stands for the normal cumulative density function. You can't abbreviate an abbreviation. Some people have a habit on a quiz or test of just putting like NCDF. You're blown out of the water. You're not even going to get any credit if you're abbreviating an abbreviation. Okay, next question. The Survey of Study Habits and Attitudes, SSHA, is a psychological test that measures academic motivation and study habits. The distribution of SSHA scores among women at a college has a mean of 120 and a standard deviation of 28. The distribution of scores among male students has a mean of 105 and a standard deviation of 35. You select a single male student and a single female student at random and give them the SSHA test. Find the mean and standard deviation of the difference, female minus male, between their scores and interpret each value in context. All right, whenever you're dealing with a difference of 2 random variables, order of subtraction is important. Make sure that you follow whatever is given, or if you're choosing it, define what you're going to do. So, no matter what with independence, you can always subtract means. So the mean of female minus male is the mean of female minus the mean of male. Those subscripts matter. Pay attention to the detail. 120 minus the 105 is 105 points. So if you were to repeat the process of selecting a single male student, selecting a single female student, and finding the difference in their scores, order of subtraction, many, many times, the difference would be about 15 points on average. All right, because the students were randomly selected, their scores should be independent. We have to make some kind of independence assumption. Remember, you never add or subtract standard deviations. Whether the initial distribution is addition or subtraction, as long as the independence condition is met, you can add variances. Then once you have the variance, you can go back to the standard deviation. Its interpretation. The difference in scores, female minus male, will typically vary by about 44.8 from the mean of 15. And then if you wanted to add this in terms of definitely emphasizing to the reader of the question, you understand an important fact. If we didn't assume the independence, then the variances wouldn't add. Okay, from the information given, you can find the probability that any woman chooses scores, that the woman chosen scores higher than the man's. If so, find this probability. If not, explain why you cannot. Okay, it never said anything up here about the shape of the distribution. For this type of problem, the only one we really know how to solve is if they were 2 normal variables. Without knowing the shape of the distribution, we can't do much. We cannot find the probability based on only the mean and standard deviation because we don't know the shapes of the distributions. We cannot assume the distributions are normal without additional information. All right, the design of an electric circuit for a toaster calls for a 100 ohm resistor and a 250 ohm resistor connected in series so that the resistances add. The components used are not perfectly uniform, so the actual resistances vary independently according to normal distributions. So there's our independence condition met. We know the distribution shapes. The resistance of the 100 ohm resistance has a mean of 100 and a standard deviation of 2.5. 2.5 is 250 rather has a mean of 250 and a standard deviation of 2.8. What is the distribution of the total resistance of the two components in a series of randomly selected toaster? So no matter what, we can always add means. They talked about independence already. If they're independent, we can add variances in order to get back to standard deviation. Find a probability that the total resistance for a randomly selected toaster lies between 345 and 355. So again, this is a format we've seen before, very common on the AP exam. You get some information about a transformed random variable or a combined random variable, and then you get asked a probability question. So that's the lower upper. Remember, for a continuous probability distribution, we don't worry about whether endpoints are included or not. Those numbers go in as is. Make sure everything's labeled. Don't abbreviate an abbreviation. Write your final answer. Okay, Ken is traveling for his business. He has a new 0.85 ounce tube of toothpaste that's supposed to last him the whole trip. The amount of toothpaste Ken squeezes out of the tube each time he brushes varies according to a normal distribution with a mean of 0.13 ounces and a standard deviation of 0.02 ounces. If Ken brushes his teeth 6 times in a randomly selected trip, what's the probability he'll use all the toothpaste in the tube? So T is the total amount of toothpaste. So his first squeeze plus the second squeeze plus the third squeeze, all the way up to 6 squeezes. Each of these guys is normally distributed, mean, standard deviation. It is reasonable to assume that the x's are independent. Okay, that's an important thing because that will allow us to add the variances, which will get us back to standard deviation. So the total mean, the sum of all the individual means, final answer, unit. Add the variances. From the variances, we get the standard deviation. Now we have the mean and standard deviation of our new distribution, and we want to find out what's the probability that he uses it all. Or in other words, that the total is greater than or equal to the 0.85. That gets us to our normal CDF. Plug in the numbers, write your final answer. Last problem for today. To save time and money, many single people have decided to try speed dating. At a speed dating event, women sit in a circle, men spend about 10 minutes getting to know a woman before moving to the next one. Suppose that the height M of male speed daters follows the normal distribution with a mean, standard deviation. The height of the female, normal, mean, standard deviation. What is the probability that a randomly selected male speed dater is taller than a randomly selected female speed dater? So, the difference, male minus female. We can always add or subtract means. If we assume that these are independent, we can add variances, which gets us to the standard deviation. We want to know what's the probability that that difference is positive, or the male minus the female is greater than 0, or the difference is greater than 0. So lower, upper, mean, standard deviation gives us that. There's about an 82% chance that a randomly selected male speed dater will be taller than a randomly selected female speed dater with whom he is paired. And that is a wrap for today.